Hi, and welcome to a video on how to solve an absolute value equation. And if you look at this particular equation, there are x's on both sides. One is embedded inside the absolute value and the other is not. So let's talk about what this looks like and what this means before we actually solve it. If you look at the left-hand side, this is an absolute value function that's been moved to the right 3 units. So you should think about the parent function and what you know about that. It's that v-shaped function, and then it's been moved right 3. And then this side is a linear function with a slope of positive 3 that's been moved up 5 units. So that is just a linear function. All right, so let's take a look at these two functions put together on Desmos. Now here we've got both of the functions graphed together, and we want to see where these two functions are equal to each other. If you look at the picture, there's one point of intersection. So essentially what we're going for is the x value of this point of intersection because our equation only has x's in it. So let's get back to the problem we're going to solve. So we're going to tackle this problem the same way we tackled the other problems. We're going to take this absolute value piece, and to get this out of the absolute values, we need to break it into two parts. This x minus 3 could equal exactly what we have on the right-hand side, 3x plus 5. Or, if we think of it as distance from 0, it could be to the left that amount from 0. So x minus 3 could equal the opposite of 3x plus 5. This is analogous to saying if we had the absolute value of x equals 7, we would say x could be equal to 7, or x could equal the opposite of 7. So we're applying the same concept just to something that's a little more complicated. So now what we need to do is we need to solve each of these problems exactly as we would any algebra problem that we already know how to do. Now, with the problem on the right-hand side, make sure you distribute that negative sign to both parts before you solve. All right, here we go. So on the right-hand side, we get x is equal to negative 4. When I do problems where I have variables on both sides, my first step is to get all of those variables together so that they're not on both sides. So I like to consolidate them to one side, and I always go for the smaller number of variables. Since there's 1x on the left and 3x on the right, if I subtract 1x from both sides, I'll end up with a positive coefficient here, which I prefer. But again, you don't have to do it that way. As long as you're using valid mathematical properties, you should be in good shape. All right, let's tackle the right-hand side. All right, now that I've finished this problem, I get x is equal to negative 1/2. Now, it's really important to check our solutions, because if you remember the graph that we looked at, there was only one point of intersection. Let's revisit that. Okay, here's our graph. We only have one point of intersection here. In fact, if I identify that point of intersection, the x value, which is the value we care about, is negative 1/2. So if we go back to our problem, it seems like one of our solutions isn't going to be a valid solution. Let's figure out why. Okay, so we're pretty sure this is our correct solution, so let's check that one first. If I plug that back into my original, make sure you go back to your original and verify that that's correct. I'm going to do negative 1/2 minus 3 is equal to 3 times negative 1/2 plus 5. Go ahead and work both sides out. They need to be equal to each other. So let's see what happens with that. Okay, so when you do order of operations on each side, you result in 7/2 is equal to 7/2, which is true, and because this is true, this solution is a valid solution. Let's check our other solution. I'm going to use blue so we can see it a little better. So again, we're going back to this original problem. We're going to now plug in negative 4. So the absolute value of negative 4 minus 3 has to be equal to 3 times negative 4 plus 5. All right, let's work out each side and see what happens. All right, when I work out each side, I get 7 is equal to negative 7. That is not true. Those two are not equal, so this is not a solution. When this happens, this is called an extraneous solution. It's a solution that appears but doesn't actually work. We need to eliminate that. And we're going to stick with x equals negative 1/2. And again, you can go back to your graph and verify graphically that that works. You can either graph in your calculator or you can use Desmos. Either method is valid. Make sure you do know how to use your calculator to verify these solutions. I hope you enjoyed this example, and I hope it helped you improve your understanding of how this absolute value function can interact with other functions we've studied.